All right, we're in section 4.6 today, negative and zero exponents. We're sort of expanding on what we learned yesterday about our product of powers property and our quotient of powers properties. Now we're working with negative exponents and exponents of zero. All right, so before we get started on our examples, I want to first start with two rules that you need to know. You need to be able to write some of these examples in your notes. The first rule says for any non-zero number, like a, well, a to the zero power equals 1. So here's what it's saying. Any number raised to the power of 0 equals 1. Okay, so here's just an example that I want you to write down in your notes. Okay, 10 to the power of 0 equals 1. You could literally come up with millions of different examples of this rule. 10 to the power of 0 is 1. 4 to the power of 0 is 1. 13 to the power of 0 is, guess what? 1. Okay, anything to the power of 0 is 1. So we're just writing a couple examples illustrating that. Now, that includes variables. So if I have x to the power of 0, that will also equal 1. A to the power of 0 is going to be 1. Y to the power of 0 is going to be 1. So it doesn't matter if it's a number or a variable, anything raised to the power of 0 is 1. Now in our second rule, it's saying that anytime you have a negative exponent, you can write it on the opposite side of the fraction to make your exponent positive. So anytime we have a whole number, you know that we can place it understood over 1, correct? So I want you to write in your notes 3 to the negative second power over 1. Everybody agree 5 over 1 is the same thing as 5? It's basically what we're doing here, okay? Any whole number placed over 1 is still the same value. All right, but what it's showing us is that you can turn it into a fraction, and when you have a negative exponent, you can simply move it to the opposite side of the fraction to make your exponent positive. This is very important when we're working with negative exponents because we do not want to have negative exponents in our answers. We want to avoid that at all costs unless the directions specifically say to include them. 9 times out of 10, we're trying to write our answers with positive exponents, so this rule is very important. All right, so now let's work another one. We don't want to do that. Sorry. Okay, now what if we had 1 over 4 to the negative third power? Okay, well the same concept applies. In order to get rid of my negative exponent, I need to write it on the other side of the fraction. So instead of it being in my denominator, it's going to be in my numerator. 4 to the negative third, or 4 to the positive third power over 1, or I could just say 4 to the third power. Okay, 4 to the third power. I do not need to evaluate any further. All right, we're just writing we're basically writing these exponents as positive exponents instead of negative. All right, so those are our two rules that are foundational for the lesson today. Now, moving into example 1. In example 1, we're dealing with powers that have negative and zero exponents. So 3 to the negative fifth power. Again, in your notes, I want you to write 3 to the negative fifth power, and I can make it a fraction over 1. And my instructions say to write it says, write the expression using only positive exponents. I'm not worried about solving or evaluating anything, but I'm writing the expression using only positive exponents. So what do we just say we can do? We can move 3 to the negative fifth to the denominator, and we can make it 1 over 3 to the fifth. And that's our answer. That's it. Now look at the second one. I have m to the power of 0. But what did we just say about any number or variable raised to the power of 0? It equals 1. So now I have 1n to the negative fourth. Okay, the 1 is separate. It's really understood. Do I need the 1 there? Do I necessarily need it there? No. But the n to the fourth, I need to be able to write as positive. So what I'm going to do is I'm going to move it into my denominator. If you put a 1 here to make it 1 n to the fourth, that's fine too. But technically, you don't need it. Okay, so it's just going to be 1 over n to the fourth. So you move the part of the term that has a negative exponent connected to it. All right, which leads me to the third example. In the third example, does 16 have a negative exponent? Yes. 16 has a negative exponent. No. These are separate terms. This is the same thing as saying 16 times x to the negative 6 times y. I can split these up. The only part of this term that is negative is the x. That's the only part that I need to move into the other side of the fraction. The other parts can remain in the same place. Does that make sense? I only move the part of the term that has a negative exponent connected to it, and that's my x. So I'm left with 16y over x to the 6th. Questions on that? All right, so now I want you to turn to page 202, and I want you to work on the first section of problems. Okay, so we're doing numbers 16, 18, 20, and 22. This is the first part of your classwork assignment. All right, so 13 to the negative 6th power is 1 over 13 to the 6th power. All right, what about number 18? 1 over 8 to the 9th power. What about number 20? X1, but we always write the number before the variable, so it would be 1x or just x. Do not write x1. Algebraically, we always write our number first. Okay, so 1x, you don't even need your 1. You could just say x, and that would be fine. All right, what about number 22? Wyatt?
6 over g5.
Perfect. 6 over g to the 5th. I only have to move g to the 5th, or g to the negative 5th, because that's the part that's a negative exponent. 6 did not have a negative exponent. That's why I left it on top. All right, who got all those right? Anybody? Okay. Anybody just missed one? All right, any questions? Any questions about what you missed? Anything? All right, moving on to example 2. Now, in example 2, now I'm not going to say that it's not important, because all the examples have their purpose, but in this example, they're trying to teach you how to write these without a fraction, how to write your answer without a fraction. So you might have a negative exponent in your answer. Now, like I said earlier, 9 times out of 10, we want positive exponents in our answer. So you're not going to see this often, but you are going to see it in your classwork. You might see a few questions on a quiz or a test too. All right, so if we have 1 over 16, and we want to write this without a fraction, well, we know that 16 is raised to what power? The power of 1. If there's nothing there, it's to the power of 1. We're trying to move anything that's in our denominator up to our numerator. So if we're moving it to the opposite side of the fraction, our positive 1 becomes a negative 1, 16 to the negative 1st. Okay, and I've gotten rid of my fraction. Anytime we move numbers or exponents to the other side of the fraction, whatever the sign was, it becomes the opposite sign. All right, so let's look at this next one, a squared over c to the 3rd. Well, if I want to move c to the 3rd into my numerator and get rid of my fraction, c to the 3rd becomes c to the negative 3rd power. Does my a change at all?
Yes.
No, my a doesn't change. My a doesn't change. Goodness. Whew, man. Okay, so a to the 2nd, c to the negative 3rd. All right, now let's look at the last one. Now in the last one, can I reduce 12 over 36? Yes, I can. I can reduce it. All right, so 12 over 36 reduces to what? Reduces to 1 over 3, right? Now I have 1x to the 3rd over 3y squared. Okay, well, if I have to move basically all of this into my numerator. All right, this becomes, now this is a 3 to the 1, okay, so it becomes 3 to the negative first power, x to the third power, and y to the negative second power. It's basically just teaching you that you can manipulate your exponents, you can move them from one side of the fraction to the other, and their sign is basically the opposite. All right, now let's move on to our classwork. We're doing 24, 26, 28, and 30 the exact same way. I'm going to show the answer. Okay, number 24, 1 over 25 becomes?
25 and negative 1.
Very good. What about number 26?
10,000 to the negative 1 power.
Okay, what about number 28?
8c to the negative 5th power.
Perfect. What about number 30?
4yx to the negative 3rd power.
Very good. But algebraically, I want to write these in order. Algebraically, alphabetically, I want to write them in order, okay? So you're going to lose a point or two for this on a quiz or a test. You've got to write it 4x to the negative 3rd y, okay? So I know that, you know, the order of it, you probably wrote it the first way, but you have to write them in alphabetical order, okay? Any questions on that? All right, now moving on to example 3. In example 3, we're combining the lesson that we learned yesterday about our products and quotient of powers. Okay, we're basically using our products of powers and our quotients of powers properties to now solve for our negative exponents. All right, so we're in example 3 now, and we're going to work some of these together. All right, now remember, our product of powers property can only be used if I have the same base. All right, do I have the same base in the first one, 5 to the 10th and 5 to the negative 6th? Now, if it's product of powers, do I add or subtract my exponents? If it's product of powers, if I'm multiplying, do I add or subtract my exponents? I add them together. But now, I have 5 to the 10th plus negative 6. You're going to have to apply your rules with integers. If you have different signs, what do? Subtract and take. What's 10 minus 6? 4, and 4 was my larger or 10 was my larger number, is positive, so 5 to the 4th power. You must write your product. You must write your product as a positive with a positive exponent. So do I have a positive exponent? Yes, I do. So I'm done. Now look at the next one. 8n to the negative 3rd over n to the negative 2nd. So again, my quotient of powers property says that I can subtract exponents with the same base. So 8n to the negative 3rd minus 2. Do you see how I did that? So what is negative 3 minus 2?
N to the negative 5th.
N to the negative 5th. But am I done? I have to write it as a positive exponent, so it's 8 over n to the 5th. 8 over n to the 5th. Got to write them as positive exponent. I like the light bulbs going off. That's a good sign. Now in the third example, I can apply both of my properties because I can simplify what's in the numerator. 6 times 3 is 18, and what's a squared times a to the 3rd? What's a squared times a to the 3rd? It's going to be a to the 5th power. Now divided by 2a to the 9th power. Well, I can simplify my numbers. What's 18 divided by 2? What's 18 divided by 2? 9. And then I have 9a to the 5th minus 9. You have to be very careful here with your signs. What is 5 minus 9?
Negative 4.
Do you agree with him? 5 minus 9 is negative 4. So 9a to the negative 4th, am I done?
No.
No, I have to move my a to the negative 4th to the bottom. 9 over a to the 4th. All right, so now we're doing numbers 32, 34, 36, and 38. Ooh, number 38 is kind of tricky. over it. All right, so 3 to the 4 times 3 to the negative 7th is 3 to the 4th plus negative 7. So it's 3 to the negative 3rd. Final answer?
1 over 3 to the other way.
Perfect. Good job. Number 34. 10 to the negative 2nd plus negative 8 is 10 to the negative 10th. Move it to your denominator. What about number 36?
You get
2 to the negative 5th plus 3 is 2s to the negative 2nd. So what's your answer?
1 over 2s.
2 over s squared.
Very good. 2 over s squared. Now number 38. What is a to the power of 0? 1. So what is 4 times 1? 4 times 7. A to the negative 4th. What's 4 times 7?
28.
28. A to the negative 4th. And move it to your denominator.
Yes, I got it right.
Got it. Good job. Good job. Good job. Any questions?
I did.
All right, let's go ahead and do now. We're skipping 40 and 42. Oops, I'm giving you the answer. Whoops. All right, I want you to do 44 through 50, and that'll be it for your classwork assignment. All right, so number 44, we have 4 to the negative 2nd minus 6, which is what? 4 to the negative 8th, and then you do the reverse, 1 over 4 to the 8th. Okay? Hopefully that helps. Now we'll do 46 through 50. Number 46, we have, let's see, and 48. All right, 46, 15 to the 3rd minus negative 4. 4 was negative, so it becomes a double negative. What does a double negative turn into? A positive. Anybody catch that? So 15 to the 7th. Okay, because we're subtracting quotient of powers property, and it's already a negative. That makes it a double negative. All right, number 48, I can reduce 15 over 3 to 5. 5b to the negative 5th minus 4 is b to the negative 9th, so I have to move it into my denominator. Now, number 50, I end up with a double negative again, because 11g to the 2nd minus a negative 4 becomes positive, so it's 11g to the 6th power. All right, did anybody get those right?
I got 3
Some of them, a couple of them. All right, they get a little tougher. It's supposed to challenge you a little bit. But if you understand that, that's everything you need to know for 4.6.